Hi everyone, so this is going to be the first of a series of videos on polynomial functions. So this first video I'm going to dedicate entirely to kind of just laying some groundwork and defining some terms. So a polynomial function, and forgive me, I'm going to write out this super crazy notational gobbledygook, but then I'm going to explain it. So this is what you often see, like if in a textbook you were to look up what is a polynomial function. This is often what you would see. So what does this mean and how do we make sense of it? So I'm going to label a few pieces of it. So this here is a term of the polynomial. And a term consists of coefficient, which in this case is played by a sub n. So I'm going to say here a sub n colon is the coefficient. And then x to the power n is the variable part. Now I'm just going to say this here because I want you to be aware of there doesn't have to be just one variable. So I'm going to write here, doesn't have to be single variable. But for our purposes, since we're looking only at functions of one variable, all of our polynomials only have one variable in them. Okay? And then a word that we're going to use a lot every time we talk about polynomials is the degree. So n, in this case, is the degree of the term. So as you can see, as we're kind of moving along here, every term has a coefficient, a variable part, and a degree. And some of you might say, wait a minute, but what about that last little guy? So this last little guy, on the one hand, it doesn't appear to have a variable part. So this is called the constant term. And if you really wanted to get technical, there is a variable part here. We just don't need to write it. It's x to the power 0, which, as you know, that's just 1. So we don't need to write it. So if you wanted to be consistent, you actually could finish this off by saying that the last term is a sub 0 times x to the power 0. But since x to the power 0 is just 1, we just don't bother. Okay, so that is the basic idea of what a polynomial is. I'm not going to leave you with that crazy definition without some examples. So, of course, you've already encountered dozens of polynomials, right? So, I don't know, here's one, 7x cubed minus 4x squared plus 3x minus 1, right? Here's another one, 4x to the 5th minus 6x squared plus 2x minus 7. So I'm just going to point this out for right now, and I'm not going to make too big of a deal out of it, but notice that we skipped powers. So in the first example, we went from x cubed to x squared to x to 1, right? So we didn't skip any powers. There was a third power, a second power, a first power, and then the 0th power. This one appears to skip from x to the 5th all the way down to x squared. It doesn't skip any more after that, but it'll actually be kind of curious. We'll talk a little bit about those skips and being careful with them, but later. All right, so that's the very basic groundwork of what a polynomial function is. I want to continue on with this idea of degree. So the degree of a polynomial. Honestly, from where we sit, the degree of a polynomial may be its single most important feature. So we already talked about the degree of a term. So the degree of a term, right, I mentioned that up here, that is the power on the variable part of the term. Well, the degree of the polynomial is the highest of the term degrees. So I'm going to go up here to the examples that I wrote up. And let's do this in green. So you see our terms in this example. We have 7x cubed. That's a degree 3 term. We have 4x squared. That's a degree 2 term. We have 3x. That's a degree 1 term. And 1. That's a degree 0 term. So 3, 2, 1, 0. What's the highest one of those? 3. So this is a degree 3 polynomial. Degree 3 polynomials are quite common, and you'll often also hear them referred to as cubic. By that same token, let's look here. So 4x to the 5th, that's a degree 5 term. 6x squared, that's a degree 2 term. 2x, that's a degree 1 term. And 7, that's a degree 0 term. So since the highest of those is 5, this is a degree 5 polynomial. Degree 5 polynomials have a name too. They're called quintic polynomials, but that's just kind of a weird word that you'll probably never actually need to use, but you might come across it once or twice in your life, or 3 or 4, however many times. And so whenever you hear people talk about a quintic, they're referring to there being 5 of something. Okay, so that is the degree of the polynomial. So it's the highest of the term degrees. Now, when we talk about functions, anytime we introduce a new function, the very, very, very first discussion of that kind of function has to be domain and range. So I'm going to dedicate this last little piece of this video to talking about the domain and the range of a polynomial function. So for the domain, this is a nice, easy one, and it's one that we're going to grow to love. The domain of any polynomial function is all real numbers. So if someone hands you a polynomial, you know already that it's going to have an all real number unrestricted domain. The range is trickier. So here's the thing. A lot of it hinges on degree. So here's what I'm going to tell you. I'm going to show you some graphs. So if the degree is odd, so the degree is 1, or 3, or 5, or 7, or anything like that, the way that the polynomial looks, and you're all maybe going to think that, wait, what is she even doing here? But you'll see in a second. It looks like this. So on one side, it goes up to positive infinity, like here. On the other side, it goes down to negative infinity. What happens in between? So that depends on the particulars, right? So how many times it'll cross the x-axis, where it crosses the y-axis, that depends on how many terms it has, what the coefficients are, all of that kind of detail. But eventually, it'll tend to positive infinity on one side and negative infinity on the other. Now, just to say we did, right, it doesn't have to tend to positive infinity on the right and negative infinity on the left. It could do it the other way around. So it could be going up to positive infinity on this side and negative infinity on this side. But again, the kind of eventual reality is that it grows beyond all bound in both directions. So don't be too spooked by these like shaded in dotted circles. All I'm saying there is those are details that are defined by the particular elements of the polynomial. So how many times, where it crosses the x-axis, how it crosses it, whether it crosses it or just bounces on it, all of that is determined by the coefficients and the particulars. But if the degree is odd, it will be going up to positive infinity on one side and negative infinity on the other. And this is significant for our range because this tells us that the degree being odd gives us an all real number range. If the degree is even, well, my friends, I'm not going to be able to tell you a whole lot except for this. If the degree is even, the eventual behavior is the same on both sides. So either it goes up to positive infinity on both sides, like this. And again, kind of what happens between these two branches, I don't know. It depends on the particulars. How many times it crosses the x-axis, whether it crosses it or bounces off it, where it crosses the y-axis, all of those things are totally determined by the particulars. But I know that eventually it'll go up to positive infinity on both sides, or it'll go down to negative infinity on both sides. So the shape of the graph is really heavily determined by the degree of the polynomial. So you'll hear me say this a dozen million times. These kind of look like funny monsters, don't they? That the degree of the polynomial is its single biggest determining factor. So what does this tell us about range? Well, not a ton, except that the range is either kind of a to infinity or negative infinity to a. Oops. Meaning that if you have an even degree, you're either going to have a global minimum and then go up from there, and that'll be your range, or you'll have a global maximum and go up to that. However, finding the location of the global max or the global min, that's not something that we can do without a knowledge of calculus. So we are going to leave it here. This is kind of all we can say about the range of a polynomial based on its degree. And we'll call this our first exploratory video of polynomials. In our next video, we'll introduce the idea of roots and factors and how they show up on the graph. See you all soon.